Our solar system came into being 13.8 billion years ago, and the Earth took its shape 4.5 billion years ago. But do you know our solar system and its planets are not the only planets in this vast universe? There's several other galaxies apart from our Milky Way Galaxy, and there's a pitch darkness between them. The dark space is known as dark matter and is 99% of the universe. The gravitational pull is so strong that even light cannot escape it. So, what we see is just 1% of the whole universe. Hence, the astronauts cannot step into this dark space as simply as we step into a pool of water. The astronauts leaving the Earth for a project in space explore the area thoroughly, and for that research, they make telescopes which make their work easy and less risky. Welcome to Cosmos Observer, where nothing goes unobserved in the universe. Since everything is dark out there, the captured astronomical images are black and white. They're presented in false color to make them more understandable and comparable. Thanks to technological advancement, now we can see some true colors via the development of new telescopes. One such telescope is James Webb Space Telescope, or just Webb. NASA launched it on December 25, 2021, and is the successor to the aging Hubble Space Telescope. It'll help astronomers look farther out into space and take us back in time. With the new telescope, astronomers hope to study the very first stars and galaxies in the universe to understand its secrets. With its golden mirror diameter of 21.3 feet, it captures 6 times more light than Hubble. It can detect visible light in the visible spectrum's red, orange, and yellow parts. The telescope will take several images under the program Treasury. The images released in a series named WOW, which means the public hashes to wait for this telescope's next set of images. The list in this video is the first part of that WOW series. The first image shows a bright star in the center, 1.6 kilometers away from the Earth. In the image's background, we can see the merger of billion-year-old galaxies. Though the focus is on the big star in the middle, the telescope's infrared lens is so sensitive that it captures even the merger of galaxies. According to the theory expansion of the universe given by Edwin Hubble, our universe is expanding. In studying distant planetary objects, there's a need to develop advanced telescopes which can see such minute details. The difference between the infrared Webb telescope and the non-infrared Hubble telescope is quite evident when comparing the same picture taken from them separately. For instance, BBF in space. Most of us are fond of spiral-shaped galaxies either because of their captivating natural beauty or because we're residing in one such type. Whatever the reason is, they hold a high position in astronomy because of the information they contain. They appear in many different forms like a seashell, spiderwebs, cyclones, etc. One such type is flocculent spiral galaxy. The term flocculent simply means fluffy. The name given is due because of its appearance like fluffed cotton. The reason behind this fluffy structure is its patchy and discontinuous arms. Its arms are not as clear as a spiral galaxy generally possesses. Next on the list is not just a spiral galaxy, but a grand design spiral galaxy, an archetype for spiral galaxies. It has been named NGC 3351. Spiral galaxies tell us how stars form, but until now this information was hidden behind thick gas and dust. With the advent of the Webb telescope, the dust will be removed and hopefully all the answers will be fetched out. The fourth is a planet named GJ1132b. This planet might have begun its life as a mini Neptune consisting of hydrogen and helium gases. Still, over some time, it has turned into a rocky planet due to the intense radiation of the hot, young star it orbits. It has lost one atmospheric layer and gained another via volcanic activity. This present atmosphere, the astronomers called a secondary atmosphere, but this will also soon dissipate because of atmospheric stripping. Also, in the beginning, it was several times the diameter of the Earth. When its secondary atmosphere will also get lost in the future, then at that point it'll become about the size of the Earth. The fifth in the list is the lenticular galaxy shaped like a lens. It lies between elliptical and spiral galaxies. It has lost almost all gas and dust from its arms and now resembles a disk with a bulge at the center. This galaxy was first discovered 200 years ago by James Dunlop. Unfortunately, the origin of such galaxies has not been known yet. Next is Abell 78, a planetary nebula. The planetary nebula is a phenomenon in which medium-sized stars like our Sun, using all the hydrogen and helium at the core to generate energy, start collapsing and turn into a hot white dwarf. The process continues, and in the next stage, the dying star throws off its outer layer, forming an elaborate cloud of gas. Although the core of the star has stopped burning hydrogen and helium, a thermonuclear runaway at its surface ejects material at high speeds. This ejection produces the filaments and irregular shells around the central star seen in this picture. This gravitational collapse is known as Type II supernova. The bursting is not only magnificent, but also important. The gases and other materials spewed by the dying star led to the beginning of the formation of a new star. A giant cloud of primordial elements consisting of electrons, protons, atoms of hydrogen, and helium creates a gravitational pull at the center, which attracts nearby several other gases and dust particles. Eventually, a new one is born. Like people die and new babies take their place. Similarly, a star has to die in the universe to bring a new star into space, and the cycle repeats. Able 78 is important because it'll soon be the birthplace of a new star. NGC 1097 is a barred spiral galaxy, and it's 48 million light-years away from the Earth. This picture reveals the intricate web of stars at the galaxy's core. Apart from this, the long tendrils of dust and dark red streaks are also visible. At the center of it lies a massive black hole with a mass of 140 million times the mass of the Sun. And at this particular place, star formation takes place. Materials that fall in black holes act as fuel. That is why young stars are in the center, reflecting bright light. The clouds of ionized hydrogen cause the glow. The ring measures 5,000 light-years across, with the spiral arms extending for tens of thousands of light-years. The extent to which the galaxy structure revealed is thanks to the Webb telescope. The idea that a single image can be taken using two different cameras is not very intuitive. However, it makes far more sense after delving into how beautiful astronomical images like this one maximize the amount of light collected. The next picture shows a collision between two galaxies which resembles a Halloween carved pumpkin that we use for home decorating, especially during Halloween parties. NASA named it Greater Pumpkin. The entire colliding space is nearly 109,000 light-years across, approximately the diameter of our Milky Way. The two glowing eyes and a crooked carved smile signify an early stage in the collision process. The pumpkinish color corresponds to the glow of aging red stars into galaxies. The smile is bluish due to newborn star clusters. The glowing eyes are concentrations of stars around a pair of supermassive black holes. The scattering of blue foreground stars makes the pumpkin look like it got all glittery for a Halloween party. The ghostly arm making the smile may be just the beginning of the process of rebuilding a spiral galaxy. The arm embraces both galaxies. It most likely formed when interstellar gas was compressed as the two galaxies began to merge. The higher density precipitates a new star formation. NGC 7678 is a galaxy with one arm, but it's still quite similar in size to our galaxy, the Milky Way. This bright galaxy is located approximately 164 million light-years away and has a diameter of around 115,000 light-years. As technology evolves, we take one step closer to unveiling the information which had remained hidden from us under the darkness of space. For example, with the Hubble telescope, scientists could peek into galaxies that formed just 400 million years after the Big Bang. But now with James Webb Telescope, they can capture images of the universe from 250 million years after the Big Bang, taking us closer to the starting point of our universe.